Hi guys, my name is Peter C. Dogwa Jr., mathematics instructor at the University of Liberia and the math tutor. In my today's video, I will be discussing finding derivatives by means of the methods of differentiation. And in previous videos, we did problems involving finding derivatives of constant functions. We did finding derivatives of linear functions. That involves the constant rule and the constant multiplier rule. So in these problems, we want to look at finding the derivatives using the power rule. That is when you have the variable and the variable is raised to the power 2, 3, 4, and above. How can we find the derivative of those functions? Now, bear in mind that we already know that the derivative of a constant, if y equals to c, it means y prime is equals to 0. A constant multiplier, if y equals to c x, it means y prime is equals to c. So we can recall from our previous problems that when you have a constant, the derivative of that constant is equal to 0. Or when you have a constant times a variable that is raised to the first power, is just equal to that constant. So in this case now, we want to look at these problems. Example number 3. They said we must find each derivative using the power rule. So the first problem says y equals to 2x to the 5th power plus 3x to the 2nd power minus 6. So how do we go about, sorry, this is t. Okay, so I should write t over there. So how do we go about finding the derivative of this function using the power rule? So we have y prime equals, so for the first term, the second and the third, we must separately find the derivative of each term. So the first one we have, again, take note of the power rule. If you have x raised to the power n, it means you should say n. That is, you bring this n down, you write the x, and you subtract 1 from n. So the same thing with this. Now it's 2. So we bring this 5 down, we write x, and we subtract 1 from 5. Plus, we bring this 2 down, 2 times 3. So we just write it so that you can see it. X, then we subtract 1 from 2. So this 6 is a constant, so the derivative of a constant is just equal to 0. So because 0 is never positive or negative, it's just 0 in the middle of it. So we just have a positive sign. So we have y prime now to be equals 2 times 5 is 10. And x raised to the power, you subtract 1 from in 5, you have 4. And then plus 3 times 2 is 6. X raised to the power 2 minus 1 is just 1. So our basic concern is not actually about factoring, but we can reduce this problem. Y prime is equals, now we have 10 and we have 6. So we find a number that can go into 10 and also go into 6. And that number is 2. So 2 goes into 10. How many times? 5 times. And 2 goes into 6 3 times. We also notice that x, so x to the 4th power and x to the 1st power. So what is common to the both of them, that is, what can you select that this can go into and this can also go into? So if we select, or let's say that you can take this expression, this factor, you can take it from this and you can take it from this. So if we select x to the 1st power, it means we can take x to the 1st power from in this x to the 1st power. We can take x to the 1st power from within x to the 4th power. If you were to select x to the 4th power, we cannot take x to the 4th power from x to the 1st. So it is not a common factor. So x to the 1st is a common factor. So you have 2 going to 10 5 times. X now to the 1st. If you take 1 from in this 4, you have x to the 3rd. Plus, now this x is already outside. So we just left with 2 goes into 6. It goes at 3 times. Now if you multiply this expression by this one, you should be able to get this. That is 2 times 5 is 10. X to the 1st power times x to the 3rd. When the bases are the same, you add your powers. 1 plus 2 or plus 3 is 4. And likewise with this, 2 times 3 is 6, and x times 3 is just x. So this is what we call the derivative of this particular function. So we'll move to the next one. We have f prime of t. So we are already mature now. We're not going to go this long route. So we just multiply. 2 times 6 is 12 t. Then we subtract 1 from this. You left with 1 minus. Now, if you compare 5t with cx, so it's just equal to c. So this will just be equal to negative 5. Or you say 1 times 5 is 5. So t raised to the power 1, you subtract 1 from there is t raised to the power 0. And t to the power 0 is just 1. And the derivative of a constant is just equal to a constant. So this will just be equal to 12t minus 5. And the next one says g prime of x will be equals, now we'll bring this 4 down, 4x raised to the third plus, multiply, 3 times 2 is 6, x, you will subtract 1 from this, 3 is 2, minus, we bring this 2 down, 2x, we subtract 1 from this, 2 is just 1, plus, this is 4x, so the derivative of a constant times a function is just equal to that constant when that function is raised to the power 1. So that's the constant multiplier. So this is just 4. And the derivative of a constant here is just equal to 0. So this will just be 0. So this is it. If you want to group the terms to further simplify, you can do that. So 4 and 6, 2 can go into 4, 2 can also go into 6. X to the second and x to the x to the third and x to the second. We can factor out x to the second because we can take this x to the second from in x squared and x cubed. So we like what we did. We are like grouping. We like grouping this term, this expression 4x cubed plus 6x squared. Plus minus 2x plus 4. So g prime of x is just equals to, so 4 and 6, we bring 2 outside. We bring x squared outside because x squared can be taken from in x cubed and x squared. So 2 times 2 goes into 4, it goes there 2 times. X squared goes into x cubed, the remainder is x, plus 2 goes into 6 3 times, and x squared into x squared is just 1. Now we have plus. Now we can even factor out negative 2 because 2 is common to the both of them. And then what we'll be left with here, negative times negative is positive. 2 goes into 2 1 times, you're left with just x. Negative times this positive is negative, right? So 2 goes into 4 is just 2. So we just, brought our solution down here so that you just have a little understanding of how we can do factoring by grouping. So if this term and this term were the same, we would have further simplified it. But you can just stop right there because we have found the derivative. This is our answer. Now let's do the last problem, h arrow. So we say h prime of arrow is just equal to, we bring this power down, 6 arrow raised to the 5th power. Now we multiply, 4 times 2 is 8. We subtract 1 from this, 4 is 3. Minus, again, 2 times 3 is 6. We subtract 1 from this, give us arrow, plus the derivative of a constant, it goes to 0. So we just cancel that expression. Now we can factor out because there is something that we are seeing that is common to all of the terms. 6, 8, and 6. So a number can go into 6 and go into 8. So we take that number, bring that number outside. 2 goes into 6. 2 can also go into 8. Also, arrow raised to the first power, arrow to the third, and arrow to the 5th. We can bring arrow to the first because you can take 1 from here, you can take 1 from in here, you can take 1 from here as well. So we open parentheses. 2 goes into 6 3 times. Now arrow to the first, you take 1 from in 5, you're left with arrow to the 4th. Minus 2 goes into 8 4 times. Now arrow to the first, you take 1 from in 3, you're left with arrow square minus 2 goes into 6. It goes there 3 times. Arrow to the first, going to arrow to the first is just 1. So we can just call this. So like I said, our primary objective is not to factorize, but we factorize to at least reduce the solution of the problem. But this is our main derivative. So after this now, we're just reducing our answer, in a factor form. So thanks ever so much for watching. See you in my next video.